Hello, everyone, and welcome. Keep coming in, don't be scared. Yes, hi, I'm Trisha. I'm a developer advocate for JetBrains. My talk today was supposed to be a little bit around a bit of an introduction to Kotlin, some stuff about what's been happening in Java in the last few releases. My thunder was slightly stolen by Venkat using a bunch of my examples in his keynote yesterday. Thanks, Venkat. But hopefully that means this is not super unfamiliar to some of you, which should be quite interesting to go through. So yes, I work for JetBrains. JetBrains invented Kotlin, so a lot of us tend to go around and talk about Kotlin. I am not one of those people. I've been doing Java development for about 20 years, and I'm really like a hardcore Java person. I'm like, I know Java now, it's just too late for me to learn something else. And it's been quite interesting to watch, because I get to see a lot of Kotlin working for JetBrains, and every now and again I'm like, oh, it's quite nice. So I thought I would use this talk to learn a little bit of Kotlin myself, show a bit of the examples of why some people think Kotlin is cool, but also show how Java is learning from some of the other JVM languages and evolving. And one of the things it's doing as it evolves is reducing the boilerplate code. One of the main criticisms of Java for many years was it's so boilerplatey and difficult to write. And as someone who'd been writing Java for a long time, I'm like, so what? What's the big deal? Why is it a problem if we have to write a bunch of this stuff, particularly when the IDE generates a load of it for us? So I kind of wanted to talk about this question of what's the big deal? Why is boilerplate code bad? Is it bad? And what does it look like in certain languages? And how is Java evolving to remove some of this boilerplate code? So, is boilerplate code really so bad? In case you have other things to do, because there are a bunch of other talks at this conference that you might want to go to, yes, boilerplate code is quite bad. You can leave now, that's fine. We're done. Yes, it's bad most of the time. Of course, the answer to many questions in the technical domain is it depends. So it depends upon the circumstances, and we're going to explore some of that during the course of this talk. Firstly, let's set out some expectations. What do I mean by boilerplate? And by boilerplate, I mean a bunch of stuff that really the compiler needs to know about, the computer needs to know about, but you as the reader of the code, as someone trying to learn something from the code, does not need to read. Often this is duplication. So for example, here I've highlighted things like duplication of type information on either side of the equals sign, things like casting, things like semicolons, things like our convention of using the word get. Do we really need to say get in front of stuff? That's not really boilerplate, it's a convention. But anyway, there's potentially a bunch of stuff in code like this, which is some of the reasons why some people dislike Java specifically, this being quite old-fashioned Java code. And of course, the point is that code is read more often than it's written. The boilerplate gets in the way of reading it, of understanding it. Generating boilerplate code is quite easy. Writing it is easy, particularly if you're using an excellent IDE, like, for example, IntelliJ IDEA. Just saying that. Uncle Bob says, indeed, the ratio of time spent reading versus writing is well over 10 to 1. We are constantly reading old code as part of the effort to write new code. Therefore, making it easier to read makes it easier to write. I don't really know where he came up with this number of 10 to 1. It is Robert Martin, so he probably just plucked it out of the air, and because he said it, it's true. But regardless, this quote still remains true, right? We spend way more time reading code than writing it. Therefore, we should minimize the noise to allow us to understand what the code is trying to do. Let's look at an example. Let's look at a Hello World example, because honestly, code talks are just not the same without a Hello World example. And of course, Hello World is what we write all the time in our enterprise jobs, isn't it? No one writes Hello World. Let's generate one of these. So let's do it in Java. Let's generate ourselves a, Hello World. And we're going to basically get, void main, we get IntelliJ to write everything for us, and we say hello. These are not cheats that I have created for IntelliJ. These are built-in cheats in IntelliJ. It just generates this stuff for us because it knows how often we need to write this boilerplate. So in order to do this, obviously we have to create a class. We have to create a method with a magic incantation of public static void main, whatever that means. And then we have to do system.out.println, because every other language says print, right? Why do we have to have 3 words to say the word print? Anyway, this is Java. It is running. It is not running. Java 12 here, marvelous. And why is my mouse not working again? Why do you hate me so much? It's this room. Every time I bring this laptop in this room, it goes, no, I'm just not bothered about working. I can tell people are looking at what you're doing. Anyway, that was an example of the new case expression. Hello world. Let's run hello world. The suspense is killing us. Just to print out the word hello. Yay, excellent. So yes, so we need like 7 lines of code to write hello to the console. I wonder why people think Java is verbose and has a lot of boilerplate. I have no idea. Let's do the same thing in Kotlin. So here, let's create a new Kotlin class. Let's call it hello. And here we can do public static void main again, public static void main, and we can do system out and say hello. So we have less boilerplate here. We don't have to create a class when we're working in Kotlin. We can create scripts like this. We can create functions without encapsulating them in a class. We don't have to say, there's not so much ceremony around printing stuff. In Java 9, we got JShell, we got the REPL. So we don't even, if we want to try stuff out, we can actually go one step further. Why is my mouse not working? Of course, I shouldn't be using the mouse. JShell console. So in JShell, I can say system.out.println hello. I also don't need a semicolon. And I can run that in Java since Java 9. Which worked? Yes, of course, it's down at the bottom. So I need even less stuff. I just have to say a single line of code, and JShell will actually just run individual lines of code. So it's way less ceremony to start trying out bits of code. So let's see. In order to write our Hello World application, writing it inside an IDE is very easy because the IDE just generates all the code for you. That's what good IDEs do. In terms of writing it in the REPL, it's a little bit more difficult. You still get code completion, but you don't get full live templates, for example. In terms of reading stuff for Java, like we just don't need all of this boilerplate. We just don't need it all. It's just noise in the way of understanding what this code is trying to do. So it's kind of, it's quite questionable how much of this we really need. Kotlin, we need less, so that's an improvement. And with JShell, we have even less. So it's quite a concise way of running bits of code. So it's better. Let's look at another example, a bit more closer to what we really do in the real life. In the olden days, so who's coding on Java? Let's go backwards. Who's using Java 11? Okay, who's using 10? Who's using 9? Okay, you know that people on 9 and 10, you should be using 11 by now, right? Who's using 8? Like everyone. Who's using 7? Okay, there's only a few poor individuals. Who's using before 7? Oh, you poor bastards. It's time to move on. Either your Java language or your job. Anyway, I didn't say that. Nothing happened. It's all right, the camera can't see you, it's fine. Java 5. In the olden days, in Java 5, we used to have to write everything on both sides of the equals sign. We have to say map. We have to say what type is the key, what type is the value. And then we have to do the same thing on the other side of the equals side. Just to make doubly sure the compiler really knows that we mean it. The IDE can hide some of this stuff for us because we just don't need to read all of that. In Java 7, this was made official, so we get the diamond operator, so we don't have to declare the generic types on both sides. In Java 10, we were like, the left-hand side, we can just get rid of all the information on there. We can replace that with var. So the type is inferred. It still has a type. It still has a type of hash map, but it's inferred from what we put on the right-hand side. Note, though, if you are using Java 10 and you are using var, you can't go so far as to also remove the type information in the generics, in the angle brackets, because then where is the type information? It's not there. So you can't go full removing all the types. That's called JavaScript. Kotlin. In Kotlin, we can remove even more. We don't need to use the new keyword. We don't need to use semicolons. I don't really know what the big deal is about semicolons, mostly because I get the IDE to add them afterwards, and I don't worry about it. But a lot of people feel very strongly that semicolons are an enormous waste of time. And now I'm a bit older, I'm like, yes, why do I need to type this? It's ridiculous. So from a reading point of view, modern Java stuff is pretty good. We've kind of removed a lot of the noise, so we can just use var if it's quite clear what the type is. and potentially, maybe we don't care about the new keyword, because actually, if you're calling a constructor, the constructor, it's quite clear that that's a constructor. That's not any other method. So maybe we don't need that. Maybe we don't need the semicolon. And Kotlin kind of goes full on, just remove all of that stuff. Dataclasses is something that Venkat covered briefly in the keynote yesterday. Let's talk about writing dataclasses in Java. When I say writing, obviously what I mean is getting the IDE to do all the work for me, because, I'm efficient. It's not lazy, it's efficient. I'm going to create a new customer. My customer is going to have a private final int age and a private final string name. And then I'm going to, let's see, add constructor parameters for both of those things. I'm going to generate getters for both of those things. I didn't touch it. It wasn't me. I did touch it. If I move that over there, very gently. OK, generate a getter for both of my fields. Generate a equals and hash code. Obviously, take all the defaults. Generate a toString. And then I'm going to call arrange code to order stuff the way that I want it. So I put all the toString at the bottom. And why is my mouse not working again? Two strings at the bottom, equals hash code getters. So I can get IntelliJ to rearrange things in a way that makes sense to me. So I've got, let's see, how many lines of code? 52 lines of code for a customer object which has two fields. If that's not boilerplate, I'm not sure what is. Let's do the same thing in Kotlin. No, that's Java, that's not what I want. We're going to create a customer class. So let's have a customer. Now, here I have to remember it's val. I don't write loads of Kotlin. Val age, int, val name string. OK. Oh, int. What's wrong with me? The capital I. Just remove those curly braces because I don't need it, and then magic incantation of data class. That's all I need to do to have exactly the same thing as my 52 lines of Java code. Now, that's kind of fine. Maybe it's not a big deal. Writing the Java stuff was easy because I just generated a bunch of it. And if I reorder the code, maybe I can just ignore all of my getters and setters and all of the boilerplate, just put it all to the bottom of the class and just ignore it as a reader. Obviously, writing from the Kotlin side, that was very easy because it's just one line of code. The thing about reading the Java stuff, apart from the fact that obviously there's a lot of code there, is that we don't know if this code is auto-generated or if it's custom. We don't know if we've overridden, if we've changed the behavior of our two-string hash code. We don't know if our getters do anything interesting. We can't really tell. Even the IDE is not going to highlight, this is a 100% generated method versus this is a custom method. Whereas if you're looking at a Kotlin data class, then when you override those methods, it's quite visible that this is custom behavior for this particular data object. So that's where the power of why do we have to generate code when we don't really know whether it's generated or not? That becomes a bit noisy and difficult for us to understand. So writing the code is not the hard bit. It's reading it and understanding what it means. There's a question or possibly a comment. Yes?
What's your view on Lombok?
Oh, yeah, Lombok. I think Lombok's quite nice. As an old-school Java person, I'm deeply suspicious of magic, and when it stops working, you don't really know what stopped working. But I think Lombok is quite a good compromise in terms of using annotations to kind of create that magic stuff without it getting in the way. So the annotation is a bit more readable than generated code. So I think Lombok is quite a nice workaround, but ultimately it's still a workaround, and it's an external library. One of the problems I found with Lombok is that when I moved to Java 9, at the time that Java 9 came out, you couldn't use Lombok with Java 9. So if you're dependent on external libraries, then things start to get a bit more tricky. Whereas if it's part of the language, of course, it's all part of the language. Data classes are probably coming to Java at some point. What shape they will be, we don't really know. Which compromises we're going to take, which form we're going to use, it depends, of course. But it's recognized that this is a sensible, interesting thing to have in the language and will probably come at some point in time. All right, let's talk about casting. Casting, yes, again, Venkat talked about this yesterday, thank you. Casting is kind of ridiculous, really, in this particular case. I've already said, is this an instance of view? And then I have to cast it to a view to use it as if it's a view. That's kind of extremely tedious and difficult to read. And in Kotlin, you don't necessarily have to do that. You just say, if it's a view, you use it as if it's a view. And it just works that way. The IDE is highlighting that in green to say, I am using this as if it's a view because you've put it inside this if object is view. There's also potentially, if this object is a Java object and could potentially be null, then you could use, again, some magic incantations, which I'm going to come to in a minute, in terms of still calling the view type methods if it happens to be a view. This, again, is something which is going to come to Java at some point, because, again, it's recognized that this is just nonsense that we shouldn't have to be writing, we shouldn't have to be reading. It's clear, if you're inside the if statement, then this object has to be a view. Surely the compiler understands that. So it will be coming to Java at some point. Let's talk about nulls. Handling nulls inside Java. So much fun, right? You have to do these amazing nested if statements, and often you don't even know if you have to check for null or not. You can't reason around whether that value is null. Sometimes IntelliJ can make reasoned arguments about, this is never null, don't worry about it, but sometimes you just don't really know if it's been checked elsewhere, if we can guarantee it's null or not null. And so I was working on a code base where basically we checked everything for null just in case. It's so much noise. I have no idea whether this is a valid code path or not. Obviously, with Java 8, you could potentially use optional. It's not really how optional was meant to be used this particular case, but you can use optional to do some of these types of things. It still feels like quite a lot of code. Optional is really useful if it's something you get back from a method and you want to say, do I have any customers that look like this? And the optional says it's empty. So you're like, no. It's a really useful use case. But in terms of kind of patching over the horribleness of having nulls throughout your code base, optional doesn't always fix everything. In Kotlin, stuff is not null, so you don't check it for null. It's not allowed. It's a compile error. Can't have it as null, which is quite a nice way of working. You don't have to think, is this null or not? Potentially, if Kotlin's interacting with Java, which is fully interoperable with Java, then you could be working with a Java object which might be null, but then you can use the Elvis operator to basically call a string of methods, and then it will not continue calling it if it's null. And it's all part of the language syntax. So the bottom code is equivalent to the top code. And as you can see, it still kind of expresses the fact that potentially customer or name could be null, but we don't have to do all this nested if nonsense. Let's talk about switch statements. So I've given this example quite a few times, and every time a number of people complain and say, but we don't use switch statements in our code. We don't use switches because they're old-fashioned, they're ugly, it means you're using object-oriented language wrong, you should be using polymorphism. That's true inside your domain. You should probably not have code like this. But ultimately, the edges of your application, at some point, you're probably getting some values that you don't really know what they are, and you need to turn them into something more useful. So for example, customer input, input from a database, input from an external system. Sometimes you just have to parse it through something like this to get the thing that you want at the end of it. So even in this day and age, we're still using switch statements. Now in Java, we have to make sure that our value is of the right type. Then we have to initialize some sort of variable, and then we're going to set that variable inside our switch statement. And when we have things like different values leading to the same, different inputs leading to the same output, it's just a little bit ugly. And then if we have anything like ranges, then we have to put all of that in a default block, and we still have if statements in there. It's a bit tedious. It's very ugly. It's not easy to read. And if you're using a when inside Kotlin, this is way more flexible. So firstly, I can assign the output of that when to a variable, or to, it's not variable, that's the point. It's an immutable value. I can have multiple inputs go to the same output. I can support ranges, and I can even check for different values. I can check whether it's an int and do something different based on if it's a different type. So I can put different types into the same switch expression. Now, in Java 12, we are getting switch expressions, so we can simplify some of our stuff. So we can do something similar. We can you can use a lambda, so it's a bit prettier, and you can assign multiple values to a single output value. As far as I could figure out, and I didn't spend a lot of time playing with this, it is a preview feature in Java 12. As you saw, it didn't compile brilliantly well inside my IDE. I believe that you're still going to need to do some of this mess for things like ranges and exceptional cases. But it's still an improvement over our original switch statement, and it's a bit less ugly. And so this is coming in Java 12 as a preview feature, which means it's not baked into the language yet, but have a try, give some feedback, see how it goes. Default parameter values. This is something I really like in Kotlin, but let's not quite jump ahead. If we're working in Java and we decide we want to have the same method but take a bunch of different values, some of which maybe we can assign some default values to, then we use method overloading. And I don't mind method overloading, or I didn't mind method overloading. It's quite a nice way, if you provide it as an API, it's a nice way for the user of your API to call whichever method suits their shape and just assume that, that your code will take care of default values. But it is kind of prone to a bunch of potential errors, which I will point out in a minute. In the Kotlin version, you just have one method and you provide a default inputs. So if you don't put in a prefix or a suffix, the default is going to be an empty string. And it's quite clear, it's well documented in the signature of that method what the default value is and what sort of behavior you can expect from that. And on top of that, you get the nice way of printing them out. So you can see it goes in the order of prefix, message, suffix. So again, a nice bit of readability there. Whereas from the Java example, it's not quite so straightforward. In fact, as I said, there's actually a bug in here. And the bug is, in case you haven't spotted it, is that here I call print message with a prefix and a message, but actually print message takes a message and a prefix. It's very easy to make these subtle switches. And you get all sorts of subtle bugs, particularly if you're using the same types in overloaded methods. So it can lead to some weird bugs. OK. Let's talk a bit about collections. Creating collections has evolved quite a bit in recent versions of Java, which I'm very happy to see because it's something that we do quite a lot of. So in the olden days, so for you Java 8 people, you have to create a list like this. And you say arrays.asList, and you create a list, and it's fine. And it works, it's all right. But what we usually meant when we typed this is we want an unmodifiable list of the list. Arrays.asList creates a list that we can't add items to, but you can still change the values inside that list. It's not actually an immutable list. So to get what we really expected, we have to do this, which is a bit clumsy. As of Java 9, you don't have to do that. You just say list.of, and it gives you an immutable list. And that's quite nice. It's marginally fewer things to type as well compared to arrays.asList. If we're going to go full mental, we're using Java 10, we can have the var keyword and static import our list, and we end up with something that's quite concise. In Kotlin, we do something similar. We could say list.of, that's fine. I really wanted to add another example here, though, so I'm just going to add some other JVM languages just to mix things up a little bit. My personal favorite is Groovy. I think that Groovy has a really nice way of creating lists. It just removes a lot of the noise. It's like you're putting stuff inside square brackets, it means it's a list, and it will just work. So I use this a lot, particularly when I'm doing testing. I use Groovy for tests, because it's quite a nice way of setting up test data without all the boilerplate noise. So lists are fine. More interesting to me is maps. Maps are a bit more difficult, particularly in Java. You have to create a map, and then you have to put a bunch of stuff on the map. And then, of course, if what you really wanted was an unmodifiable map, then you have to wrap it inside an unmodifiable map. And that is tedious, and that's not what we do. But in Java 9, we can just say map.of, which is way better. And so we can just create maps on the fly much more easily. Kotlin, we do something similar. We say map.of, and we can say 1 is the key to whatever the value is. That's quite nice and readable. But again, I'm going to use the Groovy example because I personally like the Groovy way of doing it with square braces and a colon. I just find that easier to use. Particularly, I used this a lot when I was working with MongoDB. It just maps nicely to the same mental model of document databases. So it's much easier to work with Groovy in those examples than Java, for example. OK, Lambda expressions were the big ticket item for Java 8. I don't really need to tell you about this because most of you have already been using them. So that's kind of, I don't have to educate you as to what they're like. But let's go through it a little bit anyway. We had closures in the olden days and nobody used them. So we have Lambda expressions. That's quite nice. Just get rid of all of that boilerplate and just pass in the behavior that you're interested in. Kotlin can kind of remove some of that stuff. If you're not using the parameter, you don't have to put the parameter in. You don't have to put your little arrow in. You can just use your curly braces. And I think, if I remember correctly, Groovy is very similar to that as well. So our Lambda expressions are nice and succinct. In a later version of Java, we'll be able to potentially use an underscore to represent a parameter that we're not using. So if we decide that we're never going to use that event, we just use underscore. It doesn't work at the moment in this version because it's not part of the language yet. Yes, underscore. Now that's fine when we're using Lambda expressions to call other methods. What's quite tricky to get our head around is to create methods which take Lambda expressions in Java. So let's say, for example, I want to create a method with this signature. It's called get. It takes a string, and it takes a Lambda expression. In Java, because of backwards compatibility mostly, the signature of this method has a functional interface to represent. This can be represented as a Lambda expression. And this is kind of weird because when you're looking at the method, you see root handler. This takes a root handler, and you're like, I don't really know what a root handler is. But what it means is you can pass a Lambda expression in here. Now, I've created a root handler, and I've tagged it functional interface so that kind of documents to the user. Because it has a single abstract method, you can implement that as a Lambda expression. That's kind of fine. The more idiomatic way of doing this is actually to use one of the built-in functions. So in this case, this would be a by consumer of request Java and response Java. Fine, OK? So I had to write slightly less code. But from a readability point of view, it's still kind of difficult. I look at the method get, and it takes a by consumer. And until I'm really used to working with Lambda expressions, I don't really know what that means. And I personally lean heavily on IntelliJ IDEA with smart completion to say, what am I supposed to be doing here? And it creates me a Lambda expression that I have to fill in the details of, which is nice. Now in Kotlin, the method signature is a Lambda expression. So I can see this is what you're expecting the shape to be. It's really useful from a sort of documentation point of view. I don't really have much more to say about that other than now I've seen, it took me ages to get my head around this example from Kotlin because I was like, I don't see what you're getting at. But I'm like, oh, we can't do this in Java. And now I see this, I wish we could create our signatures, our method signatures like this, because it's just a much more expressive way of documenting what's expected. Now we've talked a bit about Lambda expressions. Obviously, we have to talk about the Streams API. Now we've got Java 8, we can do filter, map, collect, etc. In Kotlin, you could do this as just as a filter and a map operation without the stream, without the collect. And because our lambdas they only have a single parameter, which I'm using, I can actually simplify that further and just call the magic keyword it as the lambda parameter. Again, it's not dissimilar to some of the other JVM languages. Now, again, Venkat mentioned this in the keynote yesterday. These two methods are not actually equivalent because Java 8 streams are lazily evaluated, and this particular expression is eagerly evaluated. So it will do customers.filter, it will do the filter, and then it will do the map. Whereas the Java expression, it will only do the full operation once you call the collect. So it's potentially more efficient to call the Java streams operation, which is why there's also a Kotlin version, which is as sequence with a toList, and then that can be lazily evaluated. So here, this is kind of an interesting example of the first Kotlin example looks like it's reduced boilerplate. But that is not actually boilerplate. The as sequence and the to list is not boilerplate. It is necessary. It's telling the compiler something. It's telling the language something. You want to do this as a lazily evaluated operation. It's also telling the reader that same thing. This is a lazy operation. Of course, which one you choose, every time someone asks me about performance, the answer is it depends. Which one you choose depends upon the size of the collection, the cost of each of those operations. Sometimes you'll actually find one faster than the other, depending on your actual operations. Now, we've talked a bit about how reducing boilerplate can improve readability. And so in theory, it should be easier for us to understand the code and to potentially change the code. The question then is, can we go too far with this? Can we remove so much so-called boilerplate that the code becomes impenetrable? Of course, we know this is true. We've read code which is succinct, which is code for, I don't know what this does. It's completely unintelligible. Let's look at an example of using var/val. Let's say you have code like this, a customer with a variable name of C, because, you've worked with code like this where you're like, how hard would it have been to type the full word customer for this variable name? But, C, because, letters are expensive. And we can reduce this. We can static import our customer factory. So then we're creating a customer. And then we can reduce this further. We can use var, obviously, in Java 10. But then at this point, we're like, what are we creating? What are we doing? We've removed boilerplate in terms of we've removed stuff we sort of don't need, but we've lost a lot of readability there. We don't really know what any of this is. So things like var, for example, should be used liberally. I'm sure you might have seen some of Stuart Marx's talks about this. You have to use it under the right circumstances because obviously you are losing information as well. So you want to lose duplicate information. You don't want to lose useful information like, what is this object C? What does it do? What is it for? I'm going to talk a little bit about Scala. Most people should know that I don't know any Scala. I don't really want to pick on Scala because I don't know enough to pick on it. We're not like friends or anything. You can only pick on your friends. You can't pick on people you just met once in a pub. I did a tiny, tiny bit of Scala for a video, and it was specifically about something called implicits. Who's familiar with Scala? Okay, good. Lots of you aren't. Who's familiar with implicits in Scala? More people than know Scala? That makes no sense at all. So as far as I can figure out, implicits in Scala are a magical way of getting rid of boilerplate. It removes a bunch of stuff that you shouldn't need to type. So for example, let's say I've got a bunch of implicit declarations here. Obviously, this is kind of a toy example because it has to fit on a slide. But I've got a bunch of implicit stuff. And then if I want to call the method materialize B, it will call it with these implicit values, these magic implicit values. And so the feature I was documenting for IntelliJ IDEA was IDE support to add boilerplate back in. Because otherwise, we have no idea what we're calling, what these values are, and it's difficult to debug if something goes wrong. We're not really sure where these values are coming from. So, and I'm not trying to pick on Scala, because Scala's got some really great features and is fantastic for particular use cases. And again, examples like this are really about use the language features with care. Don't remove all the information. It's all about who's going to be able to read these things. So it is possible with some of these reducing boilerplate features to also reduce information to the reader. So it's all about, you have to bear in mind what the reader is going to get out of reading this code. So the flip side, when is boilerplate code good? When is it a good thing to have extra code? So for example, you might argue that having the as sequence and the to list is a good thing to have. But of course, this isn't boilerplate. This is telling the compiler to do something specific. So my example of boilerplate, which is not technically necessary, is a Spock test in Groovy. Who's used Spock? A few of you. Spock is still, I'm afraid, my favorite testing framework. I'm not 100% keen on Groovy because of its dynamic nature. Yes, I know it can be compiled statically. Someone always says that. I know that. But it's still kind of a dynamic first language. But for testing, it's fantastic. I really like the fact that you explicitly state what is the thing that is being tested and your setup, your actual testing bit, and your set of expectations. And technically, those labels, the given, when, and then, are boilerplate, really. Spock does use them as the magic to understand this is a test, but really they're not there to tell, and they're basically there as labels for us to be able to read the code better. And I find this is super useful. And so even when I'm using JUnit 5, which I like a lot, I still end up putting in comments given when and then. So it's much clearer what parts of my test are doing what. I must have gone through this insanely quickly because I've got 16 minutes left. And I'm onto the summary already. This is good because I can actually cover some questions potentially, or I can really drag out the summary. It depends on how you feel. You all look quite comfy there. You look good. In summary, elimination of boilerplate code can improve readability. This is the point. The boilerplate stuff is the stuff that you don't need to put in your code, the stuff that maybe the compiler needs but the reader doesn't. So if you remove stuff that is genuinely boilerplate, you can improve the readability. It means that you can focus on the business logic that the code is trying to fix. So some other JVM languages and modern Java aims to do this as part of the language. For example, Dataclasses are a really good example of this. This is very readable. There is not 52 lines of generated code that I'm not sure if it's generated or not. It's very clear to me what the business value of this object is. Not all so-called boilerplate is actually boilerplate, and sometimes if you remove something, you actually change the behavior or change the meaning. For example, the lazy evaluation of the Kotlin filter and map. That's not boilerplate, that actually changes the behavior. Less code is not always better. Additional code can sometimes improve the readability, particularly when you're using things like var. You have to be aware of if you're going to remove the type information, are you actually removing information or are you just making it more readable? And of course, for my Spock example, it's kind of nice to have the additional code to improve the readability there. One thing I really do want people to understand, though, is that readability is entirely down to the individual. And your idea of what is readable is not the same as what my idea of readable is. Readability is often actually more about familiarity than some sort of objective value of readability. Because if it was easy to measure readability in terms of, let's say, number of characters, we would measure that, test for it, and optimize for it. And what I mean here is, for example, we have perhaps got used to using lambdas and streams, but there are still plenty of people, particularly from the Java world, who will actually find the original for loop if statement way of presenting things a more readable way of doing stuff. Everyone always said when streams first came in, oh, this is much more readable. But for someone who is not familiar with this code, this is not much more readable because we don't know what it does. And for someone who's familiar with the old-fashioned way of doing for loops and if statements, this is more understandable. Modern languages offer the option to reduce code. And we have to always be asking ourselves, does reducing the code actually make it more readable or not? That's our call as a developer. That's not something for the IDE to do. That's not something for the language to do. We have to make a decision, does this actually make the code more readable or not? All the resources for this talk, more information about learning Kotlin, more stuff about the modern versions of Java, what's happened particularly since Java 8, are at this URL. At some point, I will also put links to the slides and to the videos on here as well. At this point, I can take questions. Or you can all go. Is that a question? No. Is that a question? Or is that someone just like resting their arm up here? There's a question there.
Yeah. Do you have any comments on the Java final keyword?
Do I have any comments on? The final keyword. Yeah, final, what a shame, right? Final is kind of a big fat mess. I tend to put it in my code because I want to make sure that the variable is not a variable, that it is final. But it clutters up the code base a lot. And in fact, I don't know if IntelliJ has the option to kind of hide that. That would be nice to say, I'm going to put final in here. If you could just like hide that word and highlight the code in a different way, that would be helpful. Yes?
What about these incredibly long identifiers for classes and methods and what? What do you think about that? How should you find the right compromise?
Yeah, how do I feel about long method names, long classes, long variable names? I kind of like stuff, I would prefer longer than shorter. Yes, it kind of goes off the edge of the screen. That's a bit of a pain. But I would prefer to be a bit too descriptive rather than, I really, really, really hate variable names which are a single character. It's just lazy, right? So I would err on the side of being verbose, personally. But again, it's down to the team. It's down to what people feel is much more comfortable for them. Any more questions? It's really bright here. All right. Thank you very much, everyone.